Hey everyone, this is video number 2 in the Shooter RPG for Godot series that I'm doing. If you have not seen video 1, I highly suggest watching that video. The game that we're making is free, but this is all part of a paid course, and getting the code is part of the course. What we're going to cover in this video is largely Godot specifics and not necessarily scripting, although we will be touching on scripting, but in the future videos it'll cover more and more about scripting. If you did not follow along the last video and you want to start from the exact same spot that I'm starting at, just load up the code from the video 01 folder. By the end of this video, here's what you'll have. It is relatively basic, and it is just whatever character you've picked, you can then move around in this empty world. In order for us to show a character in the world at all, we need graphics, and I am not an artist, so I pulled my graphics from opengameart.org. I'll say the same thing I said for any other resources in the last video. Make sure you have a license to use anything you find like these sprites. And these are licensable. They say no attribution is necessary. They just appreciate a shout out to the website. And if you really want, there's an extra 3,000 other sprites. I use maybe 15 or 20 of these from the first 3,000. So feel free to go wild with this and expand the game as much as you want. There's one last thing I wanted to mention, and that's this program called PingQuant. And what this lets us do is lossily compress our image. That sprite sheet that I showed you over here is something like 1.4 megabytes, and it compresses down to about 600 kilobytes in a way that you probably can't detect even if you zoomed in on the individual pixels in a paint program. So let's get started with making the sprite sheets. And the first thing that I do to use the sprite sheet is first go into the assets folder. I make a new folder here called sprites, and I paste in the sprite sheet. Just like before with our font, when we click over to Godot, we should see it import. That dialog didn't stay up for very long, so I don't know if you caught it, but we do see under the sprites folder, we now have our sprite sheet here. Earlier, when we made a sprite, I had you click a node here and type something like sprite and then set its texture. But there's a faster way to do this, and you don't have to do it this way. You could just drag the file directly into the scene, and it will add a sprite for you whose name is the same as the file. So let's just rename this to sprite. You can see that we got the entire sprite sheet. So how do we use just a single sprite? Well, there are multiple ways to do this. So I'll show you the first way. We click region over here and click enabled. And now we have a sprite of size 00. So let's say that it's size 32 by 32. This is blank, but this is blank for a non-obvious reason. It's actually because the sprite sheet's first sprite is completely blank for some reason. So let's go over 2 and down 2. And since our tile size is 32, that means that we're going to 64, 64. And now we have this Griffin character in our game. If you don't want to type in coordinates every time, and I find that tedious, then you can use this bottom bar that says texture region, and you can expand this if you want, and then just select arbitrary regions from here. This is where using a grid snap that matches your tile size is really good, because it'll make it so that you can only select full tiles or multiple tiles, but just not portions of tiles. So we're going to set up our archer character. I like this centaur that we're using, but feel free to pick whatever you want from this sprite sheet. A couple of quick notes. One is that you can drag a sprite around, but only by its filled in pixels. So I kept doing this, and this doesn't work because these are transparent, even though they're within the boundaries of the sprite. So just be careful about that, because that definitely confused me. The second thing is that you might have heard of Atlas textures, and Godot actually supports these by default. But in this particular case, you don't need to use it because your sprite sheet is all already one file. Those who don't know, Atlas textures are typically used when you want to enable sprite batching, because binding a new texture on your graphics card is typically a relatively expensive call, at least as far as our game goes. But since you don't have to worry about that, you can just put any sprites you want from the sprite sheet down, and you'll still get very high frame rates. This game, when completed with VSync turned off, runs on my computer at something like 1300 frames per second. This particular game has a lot of camera rotations, and in order for the sprite to look nice, we want it to rotate around its own origin, this center point here. So we need to position it at the actual origin 00 in this scene, and the quickest way to do that, if I just move my head out of the way here, we can just click the position revert and it goes to 00. And at that point we can save this as our archer scene. This does not have any collision data in it yet. It doesn't just inherently know where we want this to collide with the world or with projectiles. So we'll have to set that up next. Detecting collisions is usually something you want your game engine to handle for you, and Godot can do that, but I see a lot of newcomers get confused about all the different body types in Godot. So let's try to elucidate some of that confusion here. One is a static body 2D. This is for something like trees or rocks in your game that cannot move. They have physics associated with them, so if your character tries moving into them, they will collide with them, but no amount of force on that tree will push it anywhere. There's a rigid body 2D, which you could have as something like a projectile in the game, but imagine something like a rock tumbling down a hill. That's something where you would want to apply forces to it and not necessarily say exactly how it's going to move. So for example, that rock tumbling down a hill is being affected by gravity. That's one such force. And then maybe your character can push it, which would apply some impulse to it and get it to roll, and it could have rotational velocity. You could not say, I want this rock to be moved 5 pixels higher than it is. You'd have to apply a force that will move it 5 pixels higher. Then there's a kinematic body 2D, which has some physics aware functions, but in general, you can directly move it 5 pixels higher, or you could scale it, or you could rotate it. And these functions we'll talk about in just a little bit, but they're what let you still move and collide with things without necessarily having to apply impulses directly. And that's something that I use for the characters in the game, and what I ended up using for projectiles in this iteration of the game. So we essentially won't be touching rigid body 2D in this course, I believe. Finally, there's area 2D, which is just collision, no physics. You might wonder, well, where would I use something like that? I came up with this concept of monster zones. This is not a unique concept, but in the game, there are certain trigger points where when you enter, let's say the snow part of the world, we might spawn snowy monsters. And in order to know that, we need to know that you collided with that zone, but we obviously don't stop you. This isn't even something that the player knows exists. It's just this imaginary layer hovering over you in the form of an area 2D. Even after hearing all that, you might still have the same question of, well, how do I know which one to use? And you'll find the same 2 pieces of advice almost all the time, which is, well, it depends on the game and you need to try it out. So some people will say things for certain game types, but in general, I just think it's the second piece of advice that matters. Just try them out. So let's show you what it looks like in this game. With rigid bodies, here's what you might expect. We shoot a rigid body projectile at the tree and you can see them bouncing off. So what's happening is when I create a projectile, I'm giving it a linear velocity and nothing else. So I'm saying just shoot in this direction at this speed and you figure out everything else for me. So all the physics is being covered. This next one is a kinematic body with move and collide. So you can see when it hits the tree, it's basically just stopping. There's a tiny bit of sliding at the side, but I think that's just because of how 2 circles interact with each other as they're sliding past. But if you want sliding mechanics, here's this last one, is move and slide with a kinematic body. So now you can see, unless I shoot it almost dead on, that it's still sliding its way around that body. So you'll need to test out which ones you might want for your game. And in my case, what we're going to be coding here is going to be the move and slide mechanic. We'll be using kinematic body 2Ds for almost everything. So let's add a kinematic body 2D right now to our sprite. There are a lot of little things to pay attention to here. The first is the scene tree hierarchy that we have. We have a sprite, and then underneath it, we have a kinematic body 2D. So what does this represent? Well, we know that the kinematic body 2D is what's detecting collisions. So let's say we have a wall and you have your archer and it's moving through the world and it's going to hit the wall. Well, the way that our kinematic body 2D would do that is with one of those functions, move and slide. So we move and slide, we move and slide, we move and slide, and then we hit a wall. Well, we already kind of noticed a problem as we started moving this, which is that the archer did not move with us. And the way we would fix this is by making the kinematic body the scene root of this scene. So now if I lock the children so I don't accidentally move the sprite, I'm just moving the kinematic body now. And as I move this, we see the sprite moving with us. So unless you want to write extra code to position your sprite alongside your kinematic body, I suggest making the kinematic body 2D the root of your scene tree for this character. And you may have noticed the other thing to pay attention to here, which is this warning saying that this node has no shape. So we have our kinematic body, but nothing's telling it the boundaries of where it should be colliding with anything else. We have this sprite, so maybe we could just tell Godot to render every pixel as a collision boundary. And you actually can do that. You click sprite here and then you click collision polygon 2D sibling, but it tries to make it on the whole sprite sheet. Even if we had just a single sprite and we could do that, let's say we had this sprite, generating those polygons is going to look like this, which is something like 20 polygons and is probably not the most performant. So I generally would shy away from that. Usually we can make 1 or 2 shapes and we can approximate this entire thing. So we will add a collision shape 2D. and you can pick all the different shapes up here. So let's make a capsule and let's rotate it by roughly the amount that I figured out ahead of time. And then for this, I have this button selected here, which is that the children can't be selected individually. So if I try dragging this capsule right now, I'm actually dragging the whole thing. So I need to turn this off first, and now I can drag the capsule. And so we would set this up. I'm not going to make this exact. And then we'll add another shape, and we'll make this one a circle, and the circle can cover the torso of this sprite. So in general, make as many as you want. If I knew that this character was going to be for only the player, I might make this a little bit more generous here and say, well, you can't get hit unless you're hit exactly on the head or exactly on the legs. So this is all for you to decide however you want to make this game. Let's apply everything we just did and make a warrior as well. So I will just save this as a warrior. And now we'll need a different sprite. The warrior sprite is in the 8th row, roughly over here. And now let's take a look at a little bit of a problem. Let's say I deselect this sprite. Do you see this effect that's happening on the top? This is bleeding in from the surrounding sprites, and it's something that we can fix in Godot. We left click our file and go over to import up here, and then make sure that filter is turned off and click re-import. You can see our graphics got a whole lot sharper. What it was doing is some probably bilinear filtering to try to make sure that this looks smooth. And we don't really want that because this is pixel art. So now that smoothing is also not causing the bleeding to happen because we turned it off. So now we can set up the collision shapes for these. I think 2 circles works pretty well for the warrior. So we'll just change this to a circle and roughly do this. That looks pretty good. The final character we have is the mage. So again, we'll save this as the mage. And we'll go pick our sprite for that. Got it. And then those shapes already look pretty good to me. We could customize these. You can make them rectangles or capsules. That's not super important for this video. You know how to do it now. At this point, you may do what I just did and say, yeah, I should put those characters on the character select screen now, right? Why not? And part of the reason why not is because Godot's docs say to make your life easier, always use control nodes wherever possible and not sprites like we had there. So that would have been a sprite, and it also would have had a kinematic body on it, which we don't need because there's no collision on the character select screen. So how you would do this instead is you would add a texture button. This is a little bit unusual because I said we wouldn't need Atlas textures, but you do for the sake of texture buttons. So I'll go through this process, but I'm not actually going to modify the UI. So let's see what it would look like at the very least. We make a new Atlas texture, and then we drag in our sprite sheet. And now we can select, just like before, arbitrary pieces of the sprite sheet. You might wonder, why isn't this showing up? And I actually don't know the answer for that. I think that's a bug. You have to toggle the visibility and then it shows up all of a sudden. And so this is how we would narrow this down to say, we just want this character on here. We would have a button that looks like that. And that's where we do need to use an Atlas texture. There is no region property on the texture button. I'm not going to spruce up the UI, but I am going to spruce up the code for the UI. So in here, we had hard-coded values for archer, warrior, and mage. Why are hard-coded values bad? Well, 2 major reasons. One is that if you wanted to change archer in the code base, you'd have to change it everywhere that you hard-coded that value. And 2 is that it's not obvious what it represents. Is it the name of our character? Is it the sprite? Is it the character class? So what we're going to do is we'll make a constants file. So right-click scripts and go to new script and type in constants. And then we have to open it. I don't know why it doesn't auto-open. And we paste in our constants. So let's look at what this is doing. We have an enumeration, and the way that enumerations work in GDScript is that they are 0 indexed values. So we don't set strings for them. That means that archer is going to be the value 0, warrior will be 1, and mage will be 2. And that these are the only possibilities for our enumeration. Then we are letting the editor infer the type of this. So this is a dictionary. It's just like in Python if you're used to Python. And we say that for each character class, we want to say what scene it corresponds to. And these are the scenes that we made. So if yours are at different paths or have different names, or you have different characters that you added all together, then feel free to customize those here. In order to use this from another file, we have to make sure that it's loaded in our scene tree. Godot has a feature for this called auto load, so that we don't need to manage this. We just go to project settings and then auto load, click this button and pick our script. And then don't forget to click add up here. I've forgotten to do that before and it doesn't work if you don't do that. When we run our game now, if we go look at the remote scene tree, constants is there, and we didn't have to add that ourselves. That's what autoload is doing. So now if we were to type out something like constants.characterClassNames from any other script file, it should just work. To test it, let's actually make the change. So we can go to our character select class and we can replace Archer with the correct character class name. And let me maximize this so you can see everything. And then same thing here, we'll replace this with Warrior and we'll replace this one with Mage. This is just the signal side of things. So we also need to replace where it's being connected, which is in main. In main, we have this character class that used to be a string. You might want to try to change this to constants.character class names, but as of Godot 3.2, you cannot do this. But since enumerations are integers, you can change it to an int. So we can change that here, and then we would need to modify code in our gameplay scene in init. The script that we're going to use is actually one that I'm going to paste in here. It's got the same init function, but it takes in the correct typed variable. And what this function is doing is it's reading our dictionary from constants, which only had one member variable in it, which was scene path, and it's going to load that. Now, the reason we can't do preload here is because preload works at build time, and at build time, we don't know what character you've picked yet. We can't predict the future like that. So when we save and we run this, we are going to get your character that you chose, and it's going to be off screen because we set the origin to be 0, 0. But this is where we can use the remote view and find the path to our character. Here it is. And we can just change the position of this. So we can say something like 50, 50. And now we know that the character that I pressed 1, so I chose the Archer. We know that the character that we picked is the correct one that we instantiated. Before we forget, let's delete the label from our gameplay because we're not going to use that anymore. So gameplay is just an empty node into which we will instantiate things like the world and the player. And our player can't actually move right now. What we have is just instantiation, and then again, no keys on the keyboard will make them move. So we need a script for them. One way we could do this is when we instantiate the player, we could do something like this, where we say, go load a script, which I haven't made yet, so it's going to error right now, and then call set script on that player. So that is one way to do things. We could do this dynamically. Another way we could do this that you might find more straightforward is, let's say we load in a scene like our Archer. We could just set over here that it has a script on it. So we can make a script here. And I'm going to call this one player controller. By doing this though, you're saying that all archers need this player controller script. And if this is something like you're pressing arrow keys and controlling the character's movement, then it means you can't really have enemy archers unless you turn that logic off. So one way, if you wanted to have enemy archers, and for this game we're just going to say that they won't exist. The only archer will be the player archer, so it's fine to have this script. If you wanted that, how you might do this is you might make a new scene and you might just instantiate Archer into this scene and then set the script on this one to be player controller, and the base Archer class just wouldn't have a script on it at all. We only added the script to the Archer though, so we also need to load up the Warrior and attach that same script. And since we already have this script, we can just path to it, scripts and player controller. And we'll save that scene, and then we'll load up the Mage scene as well and attach our script there too. Scripts and player controller. Now we need to flesh out the script itself. So let's paste in the code, maximize this, and we'll examine it. Let's start at the top with init. Remember, init is just our convention that we're using. We could have called this construct or anything else, and we're not actually calling the function yet from gameplay, so we'll need to do that too. But this is the entry point for this script, and we're passing in the character class and pulling the character class info from constants. We're then not using it at all. That's because this is a placeholder for the future when we're going to pull abilities and stats from this object, and I wanted to show how that structure is going to appear in the future. We're then putting our character on the screen. It was at 0, 0 before, so it's showing at the upper left corner. And we're setting the name. This is something you might have noticed that I didn't do here when I made the Archer. It's still called Kinematic Body 2D. And really, the best reason why I didn't do this is just to show you that you could do it both ways. The real reason is laziness. When I save this, I end up saving it as something like Monster or something like Arrow, and I just don't like having to rename that every time. So instead, I just do it in the script that's attached to this node. The next part, we see this unhandled input again, and now it's time we talk about what makes it unhandled. Godot has certain rules for how input gets routed through scenes. So for example, I believe the UI layer is going to get it first, and then it'll try passing it down to any other layers, and they could always mark it as being handled. So at this point, we know that it hasn't been handled by anything else. This could be useful if you have a dialogue showing up above the gameplay screen that says something like press space to continue, and you don't want space to then trigger something in the player as well. Every once in a while you'll play a game where you'll find a bug where you click something in the interface and it still shoots a projectile in that direction. You wonder, why did that happen? Well, that's where unhandled input can help us from stopping that. It's clear what this code is doing to you most likely, even if you don't understand exactly why. When you press right, you're moving to the right. And when you press down or up or left, you're moving in those directions too. But let's examine two things that might not be very obvious. One is, why is velocity defined here and not used until physics process? Well, part of the reason why is because unhandled input is just a time for us to process the input itself. So we store into a member variable what velocity we ended up with. And that way, in the physics tick, which might happen on a different part of Godot's event loop or on a different timer entirely, we can process that velocity. The second thing you might be curious about is, what does this normalized property mean? In order to understand that normalized property of vectors, we need to first understand what is a vector. And in our case, they're vector 2's, just meaning that they have 2 components instead of 3 components or 4. It's anything you can represent with those 2 components. So for example, a size, a velocity, a position, anything. With that code that we had, it was velocity.normalized times the speed. Well, let's look at a vector like this. This is not a normalized vector. This has a direction and a magnitude. The direction is a little bit north of east, and its magnitude, without going into the computation, is about 8. It's the length of that vector. If we were to normalize the vector, what we end up with is the same direction, exactly the same as the red one, but now its magnitude becomes 1, which makes it the unit vector. If we had determined this to be the velocity for the player and we didn't normalize it, then we would be moving about 8 times faster than we intended to. So that's why we normalize our vectors. That way they always turn into just a length of 1, so that when we multiply it by our speed, we're just moving by our speed in any particular direction indicated by the vector. Coming back to the code, let's look at the last piece of the puzzle, which is move and slide. Remember that this is a function that exists on kinematic body 2Ds, which gives us some interaction with the physics system without losing that property of being able to position or rotate our kinematic body directly. So let's say you had a surface like this and your archer was moving in at this rate. With move and collide, you would just hit this and stop. But with move and slide, you'll continue sliding smoothly along the surface, which is generally what you want out of games like this, so that you smoothly move around walls and around obstacles. One other thing that I noted here in the code is that the delta is already calculated. If you were to control click this, you would see it somewhere over here. You should not multiply by the delta. Remember that delta is a fraction of a second. So by doing so, if we were to multiply by this delta, which again, you're not supposed to do, then we'll see our character move very slowly, because this is something like 1/100th of a second every time. So we're moving at roughly 1/100th of the speed. You may have noticed something strange there, which is that we're still starting at 0, 0, even though we have code to stop that from happening in the init function. By the way, let me remove that delta. The reason why is we're never calling our init function. Remember, Godot is not calling this on its own. So if we go into our gameplay script, we can call this here, player.init character class. And now when we run this, we'll be positioned at 50/50 by default. For this game, I like using WASD controls, and we already learned how to customize the input map. So here we had UI left. We could just add another key. We don't even need to remove the left arrow. And same thing with right, up, and down. So I'll customize those too. There. And then I would test this out, of course, by running the scene. And yeah, it works. It's about time we took a look at debugging. Let's say your code isn't working and you've put print statements in and you can't figure it out. That's generally a case when you should dive into the debugger, and Godot makes it very easy. You just left click once in the gutter on any line of code and you'll put a red dot there indicating a breakpoint. When this line of code gets hit, it will now break into the debugger and you'll be able to inspect what's going wrong. You don't need to start Godot in any special way. You just click the play button as normal. And that code we know gets hit when you press an arrow key. So I'll press up on my keyboard and it breaks in. And now if I move out of the way a little bit, you'll be able to see this. You can see that X is 0 and Y is -1. Now, we don't actually have a bug, so that's what we expect here, but this is generally the process you'd go through to debug and figure out what's going wrong. With your attention now on the debugger, you might have noticed this number 2 next to debugger down here. This is indicating that we had 2 warnings this whole time that we've never fixed. And they're both the same warning, actually. What they're saying is that connect and move and slide are both returning values that we're never looking at. So there are 3 things that you can do about this. One is in project settings, you could disable specific warnings. So in this case, return value discarded, we could just turn this off if we wanted to. 2 is that on particular lines, let me move my head out of the way again, you could see there's this warning here. I could click that and we could click ignore. And what this does is it adds a special comment indicating to Godot that it should not consider this warning at all. And the third thing we can do is address the warning. And this is what I generally suggest doing. In this case, we could say ignored equals and then the return value of this. However, now this is going to turn into a different warning saying that we're not using the value ignored. What Godot has as a way of indicating that you're intentionally not using a variable is to put an underscore in front of it. And you actually already saw that happening over here with delta. So if I apply this in both locations and then I run the code again, we don't see anything show up in the debugger and our game is working as we expect. We added collision, but we never tested it. And this I find pretty interesting. So let's do this. Let's go into our gameplay scene and let's instantiate a mage, and we'll make this pretty big. So we'll go into the transform, we'll set it to 5.5 and position it in the world. Now we're going to start up the game and I'm going to pick the archer. What do you think will happen as I move toward the mage? Well, if you've been paying attention, I have the player controller script on the mage as well, so I can never move over to the mage because I'm moving them both and their distance will always be the same between each other. So let's just go remove the script from the mage and start that again. And now what do you think will happen? Well, now our colliders will work. And you can see it's a little bit rough. I very hastily made the collision shapes because these are supposed to be very tiny so you wouldn't be able to tell that you're not totally colliding. But let's also look at one other property. I'm going to move over here and I'm just going to hold the left arrow on my keyboard. And you can see that my character pathed around the bottom of that circle shape that there was. That's happening because of move and slide on the kinematic body. So there, we've tested our collision and now we know that this is good to go. Wrapping up, I think the biggest takeaways from this, one would be to try out different collision types, the kinematic body 2D, rigid body 2D, and see how they'd impact your specific game. And 2 is, and I can't stress this enough for practically any language or game that you're going to make, is to debug sooner rather than later. Again, if you find yourself spamming print statements, you should probably be debugging instead. The code for this video you'll find in the video 2 folder. I really hope you learned something from this. Thanks again for watching, and please consider going and checking out adamlearns.com for the full course. Bye.